So my name's Gareth Jones. That's the introduction. I'm an architect at Microsoft. Been at Microsoft for about 27 years now, which is kind of a long time. I've spent about the last 10 years in the API space, building APIs across things as weird as Visual Studio, OneNote, and a lot of that time working on a product Microsoft Graph. And I'd like to spend about the next half hour talking to you about how we kind of got to where we are with open APIs, just a whistle-stop tour through that, and kind of what's next, both in tooling and in open API. Sound good? Now, I do want to acknowledge my clickbaity title. I'll get to that in a little bit, but it is kind of clickbait. So we've been talking about how computers can communicate with each other. I think maybe for almost longer than we've had computers. I'm not really sure where they dug this article up for, but apparently sometime back in the late 1800s they were talking about API discretitations. So yeah, I don't know. These academics, they can find some weird stuff. But I'm going to start our journey in the 1990s. And we were struggling with technologies like Corba. Anybody around for Corba? Yeah, a couple of you, wow. Where it was kind of awful, to be honest. We were like directly accessing over the wire stateful OO objects in some other machine, and really that's not a thing to be doing. And we learned that lesson, and it was painful. But what did come out of that was knowing that we had to separate our implementations from the description of the services that an object was providing. And so at that point, really the first commonplace IDLs, or interface description languages, came out. But then we fast forward into the 2000s, and we'd moved away from all of that Corba junk and trying to do remote objects. And we were talking about web services, and we were all using technologies like SOAP and WSDL. Seen any winces for WSDL? That was not a fun way to describe APIs, but got the job done, and we were learning. And really, in many ways, it was the first popular web-centric IDL. But then, by the time we were turning over into the 2010s, then really the pointy brackets of SOAP were becoming unfashionable. We weren't using XML. We were all rushing to JSON-based APIs. Pointy brackets out, braces in. And we got to that point where people started to bring out new definition languages for the new generation of APIs that people were building. So in 2011, Tony Tam launched Swagger. And then in 2013, in I think April and September respectively, API Blueprint and RAML came out. And we've got these new languages then at this point, in this loose sense of competition, that are all sort of vying for attention and all have a slightly different take, whether that's being more centered on the design, more centered on accurate descriptions. They all had their own communities and their own things they were great at. And communities started to form around both the individual the individual technologies and the broader API community. And we started to get together in conferences and debate the merits of these things. So what were those early conferences like? Was it, well, these fellows seem to be kind of having an intelligent collegiate discussion. I'm sure it was always like that. I don't know. My memory is that it was maybe a little more a meeting of minds, but a little bit pointy, a little bit feisty at times, once in a while. I don't think it was like this all that often. Maybe that's because none of us ever wore ties. I'm trying to think of kin in a tie. That doesn't seem like a memory I have. But this is the period, gentle colleagues, that is loosely described as the API description wars period. And it's very hyperbolic. And I don't really like using this kind of wars metaphors. But we did have some fairly entertainingly robust discussions about the merits of these things. And I tend to think tech companies are at their best when they're funneling their ideas through the sharpness of competition. So you know, it's a period that I do actually look back on fondly in terms of those discussions. But eventually, we did kind of coalesce around Swagger, and then the OpenAPI initiative was formed. We renamed everything to OpenAI specification, and that really kick-started the breadth of the community, really, and allowed our vendors to get focused. And in that focus, to be able to say, well, we're mostly only supporting one language now, so we can support it much deeper and have much richer implementations. So as we're seeing the community build, we're obviously iterating on the language. We go through to 3.0, 3.1 of OAS. And I think we're really all fairly clear at this point that OAS is providing us with really great tool support, really great interop for our languages. And it's kind of, you know, the lingua franca that we can all understand and we can all expect things to be based around. And just a sort of simple example of that, if you look at where we were 5 years ago with SDK generation tools, well, generated SDKs were pretty rough and ready back in those days. There were often gaps in them, the difference between what you could do through the SDK and what you could do making calls to the raw API were often certainly out of the box. Pretty intense differences. And we had to go and do a lot of work as people who owned SDKs to go and take those and get them to the point where you could actually get them to a level of usability for customers. But where we are now, the level of detail and information that's in an OAS that for any given SDK, we're getting to the point where the generated SDKs are really very accurate and very usable pretty much straight away. And you can see from the plethora of vendors working in the SDK tooling space in the vendor hall here this week, tools like Kyoto from Microsoft that we recently open sourced for providing SDKs, that this is a pretty vibrant part of our ecosystem. We're really kind of nailing that at the moment. So, is it all great? Everything perfect? You all happy with everything about our OAS infrastructure? Maybe. I sort of spread the kind of things you can do with OAS across a bit of a spectrum here. And I color coordinate it beautifully, I think. And kind of over on the right, you've got all the very, no, your left. No, the right. You've got all the sort of very technical aspects of it. All the pieces which are very much driven off the detail and really flow well as we get these very detailed OAS specs. So runtime validation, SDKs, mocking, linters, great documentation, plugins for low-code tooling, all of those kind of things. On the right, the more sort of softer end of things around design and how we do governance, more process-oriented things perhaps as well, about how we go and involve other business stakeholders. So I'm going to come back to the left side, but I want to kind of motivate the left-sided discussion a little bit. I really wanted this slide to be higher, further, faster, so I could go all Captain Marvel, and I just couldn't make the words work, so deeper, wider, higher. We're scaling up our APIs tremendously. Let's talk about that scale, right? If you caught Mandy's talk yesterday, she was talking about the fact that at Microsoft we have some pretty extreme problems of scale with the number, volume, and depth of APIs that we're producing. But honestly, I think it's directional for our industry. I think we're just kind of a leading indicator, us and the other large tech companies, that this is the direction we're all going. There's so many vectors of scale that are kind of exploding this space. Whether that's more protocols, we're not just building REST APIs. You might want REST and gRPC for the same APIs. You might want an eventing system that's described with async API. Well, that's a lot more information and data you've got to encode. Obviously, just a lot more endpoints. Everybody's inventing new features every week. every month, and you've got to just, grow your API descriptions to cope with all those new features. But then detail, right? We've talked about having great SDKs now. Well, those great SDKs require that your OAS files contain absolutely the finest detail about how your API works and describe every little bit of context that you need to be able to make a successful call across the entire surface area. That bloats things out. Versions. As soon as we've got customers, we've got to deal with backwards compatibility. When we're dealing with backwards compatibility, historically we invent a versioning model, and we've got to deal with that. And again, that is another vector of scale that blows things out. And then people. James was talking yesterday about a set of APIs where the customers were in the 10,000 range. Well, that's a lot of folks to make sure their concerns are all covered and that they want everything that they need in our files. So a lot of different things that are causing pressure for us to have more and more and more stuff described by our API descriptions. So I want to pick on one data point, and I've pulled out just a few common APIs for things you've likely to have heard of, Gmail and Jira and GitHub and our own Microsoft Graph technologies. And you can see from the right-hand end with the Microsoft Graph, we really are in the place of some fairly extreme scale here. But the comparison here is that the blue line with the left-hand scale is how many operations there are in the API, and the right-hand scale is how many lines of code there are in the corresponding OAS file for that API. And well, the two lines are working together reasonably linearly, right? It's not the graphs are not drifting off from each other enormously. But it's nearly 2 orders of magnitude difference. And that's just too much, right? If we're talking about working with these files, particularly for design and governance activities, well, if my files are in the, hundreds of thousands to, to at the far end, millions of lines of consolidated OAS, I just can't work with that sort of information. It's not in the bounds of me being able to process it as a human. And certainly you try and get, business folks who really don't want to be focused on the technology to look at those sort of OAS files, they're just going to switch off, right, and just be like, what on earth are you pointing me at this for? So, and that's kind of the reaction you get, right, for all of us, I think, to some extent. The human experience for things, once we get to the scale we're at now with OAS, is just really tiring, is the word that I ended up picking, to be honest. So coming back to my left-hand side of my slide, for these things, the tools are not, causing me to want to put on that pink T-shirt in the same way as they are on the right-hand side. So, something's probably got to give a little bit. So a quick straw poll, who works with OAS files in their day job, or Swagger even? So most of you, right? Keep your hands up if you enjoy creating and reviewing those files. Okay, a couple of you. Clearly a little masochism in the audience. No judgment. It's okay. You're not betraying the API conference cause by not being wholeheartedly enthusiastic about wanting to write the world's biggest YAML file, right? We're all human, and recognizing these things is the first step to change, right? So, so let's see what tools we've got. Well, I think generally speaking, when in computer science we get overwhelmed by detail, we reach for the tool of abstraction, right? That's our first port of call, and we try and lift ourselves up a little bit out of that detail. And as we lift ourselves up, we then say, okay, there comes a point where we need to put the detail back, and then we slide in patterns. And those patterns provide us back with that layer of detail to implement the abstraction. And also, because we're choosing patterns, they give us consistency of implementation, because we're not just inventing something new every time. And I think it's really this kind of tension in the system between the semantic comprehension of the things that matter to you, particularly in the early stages of design and review, and then the operational detail needed to actually run and use and consume APIs. But it's not just about abstraction giving us a removal of detail from a sort of technical and competency point of view. I think it's really important to recognize that, you know, abstraction is a tool for changing the note of the discussion. You know, it wouldn't, if for those of you who've been to one of my presentations before know there wouldn't be a presentation without there being a cat in it somewhere. But in an abstract picture like this, we're not fussed about the details of the exact, you know, quality of the cat's fur and whiskers and what have you. We can appreciate the cat perhaps more structurally. And we might notice, for example, that the cat is in stretching mode. Well, that might lead us into a discussion with our business stakeholders who are pretty interested in cats, I can tell you. That there might be other important handsome cat poses that our API needs to deal with. It's not just about stretching cats. Well, you know, maybe we shouldn't have woken the cat up in the first place and asked it to do stuff. These are the sort of things cats get pretty irritated about, right? So that ability to take the discussion out of being lost in the detail. Detail brings with it a kind of cognitive baggage that tends to hog and weigh down our discussions. Whereas when we elide some of that detail, then we can actually free ourselves up to have a broader set of discussions without feeling like, oh my goodness, it's overwhelming to bring in, you know, scenario 2 and scenario 3 and scenario 4 because they just, you know, have this ton of stuff behind them every time we add something new. So, I'm going to talk about a couple of tools that take an approach to using abstraction to make some of these stages in the API lifecycle a bit easier. And then I'll touch on where the OAS is going in a similar space. Sound good? So let's start with an OAS file. Now, I am not expecting you to be able to read this, tempted as I was to insert a quiz after 5 minutes of staring at it. But I really just wanted you to get a sense. So this is an OAS file for a very simple weather service, just a kind of handy-dandy example. And I've highlighted the fact that there are 4 endpoints in the service. So you can get cities, some more detail about a specific city and the weather forecast for it. And for some reason, there's a get current time function. I have no idea what that's doing in a weather service, but hey, we've all got APIs like that, right, where there's just a random outlier. And this is the example I happen to pick. So there's about 100 odd lines, and there's a lot of boilerplate in there in terms of the, you know, how I shape the parameters and the fact that everything can succeed with the 200 and stuff like that. Well, yeah, you know, Sherlock might not need to worry too much about that, right? That's kind of how we build APIs. So let's have a look at how we might model that with some of these new tools. So Smithy is an API description language from our friends at Amazon. And it's a more abstract language by its nature. So you can see those same 4 endpoints being called out in here. I've re-highlighted them again. But the way Smithy describes these things is to take an approach that's not so tightly bound to the technology strata as an OAS file is. So it's pulled us away from saying this is an HTTP implementation. This Smithy file could be used to generate gRPC. It could be used to generate pretty much any protocol. And that's sort of a characteristic, as we'll see going forward here. So let's zoom in on a little bit of this. As I'm sure, as I say, you can't read any of that. So we might define one of our resources to say there's a city in our weather API, and say that our city has a single identifier, it's city ID. But you'll notice the type of the city ID is also city ID. We're not using, you're just saying, hey, there's a string or a GUID for the type. We're actually saying that we've defined a specific identity type. And that identity type in this case, I've not pulled that up there, but it's a regex pattern to say that they all of the identities follow a certain pattern. And then there's a bunch of other properties, this case coordinates for the city, a couple of operations defined against well-known semantics for read and list, and then the idea that the resource has sub-resources, in this case the forecast for the city. So pretty simple, pretty clean, and I could then go and add in HTTP bindings to take this through to say how this maps onto URLs for an HTTP API, or potentially have a standard transform that says, well, this is a normalized way that things get transformed to a particular protocol. So, nice and clean and simple. So now this is a TypeSpec definition of the same API. So TypeSpec is a lightweight API description language from Microsoft that we've recently open sourced. Again, you can see I've pulled out the 4 paths, and you'll also see that it's really very terse. It's a very small file, relatively speaking, for the same information. And I'll again zoom in a little bit. So that's the same call out for modeling the city. And again, you can see that it's saying it's got an identity, defining that identity type, coordinates, and that there's a forecast sub-resource with a chance of rain in there. So I'm going to dive in a little more with this one and look at how the paths actually work. So we're modeling this by saying that there's a group of paths together, and a group of operations, rather, in an interface for our listing of the cities, and that I've been able, because of the way the syntax works, to coalesce 2 of the paths, which are cities and city/city ID, into one nice expressive bit of operation grouping. And again, I'm expressing those path parameters that I have to pass in the city ID, and the fact that I've got pagination, which was in the Smithy as well, with tokens and page sizes, and that I might return an error, and no such resource you'll see down on the end line there for when I want to return a 404. But again, you'll see that the core structure that I just showed you, the model, wasn't particularly bound to HTTP. With this one, even in that small file, I'm able to include the HTTP binding directly in line here. So can we go and add some even more interesting data here? So the way TypeSpec works is essentially it provides you the ability to add in libraries that are specific to your domain. In many ways, it's like a domain-specific language platform for you to be able to take an API description and shape it to the kind of APIs that you happen to build. I'm a huge DSL fan. I spent a lot of my career building DSLs, so I tend to see things through that lens. The rest of the team are sitting in the front row, and they're maybe wincing at this point, but that's definitely the way I see the world. So we built a library to go and add in things for things we care about in our APIs, and we have a pattern. If you imagine for a moment that getting the weather forecast takes a few seconds for some unearthly reason, I don't know why it should do, but we want to say that anything that runs that long, we have a pattern for dealing with long-running operations. And that pattern includes things like returning a 202 status code, returning a location header that tells you the URL where you have to go and poll to go and find the result of the long-running operation. So you sit there calling get on that repeatedly, and what kind of shape the data from that polling operation needs to be. And all of that would be quite a lot to describe in an OAS document, and also quite hard to make the connection between that polling endpoint and the endpoint that you were originally originally calling to get the forecast. Whereas here, we're saying, hey, that pattern, which is in our pattern catalog named stepwise, we're just saying, hey, this is a long-running operation, get forecast. It's using our stepwise pattern. And to be honest, I could have stopped at that, but I also added in, and this is the polling URL. But if you happen to be saying, hey, this is a standardized place for the polling URL, you could just drop that and just say, hey, this is a long-running operation conforming to our stepwise pattern. And as a designer, that's really all I want to say, because I know that anybody who's implementing that should implement it in a standardized way by following the pattern guidance. I don't need all the detail. All I want to do is be able to say, I'm using this, and then as governance say, oh yes, things that have taken a long time, you're using a standard pattern for. So hopefully that's pretty clear then to any reader coming along to this API. So seems to me we're back to something I was describing earlier, and I guess where I come to my clickbait to some extent, right? That we've got a couple of languages here, and they're both using abstraction with different priorities and in different ways to tackle, what are the current challenges in the API design and governance space. So I'm not going to use the meme again, but there's certain similarities in where we are now and where we were then, right? So, what's the OAS doing in this space? Well, who here is familiar with Moonwalk? A few of you, okay. So Moonwalk is the next generation of OpenAPI after 3.x. The graphic is very nice, I think. And it's very early days at the moment. They've got a target of the end of the year to have something significant out. But they've said there are going to be 5 focus areas, which I've put up here. And I think for the purpose of our discussion, the 2 that are kind of the most interesting are the semantics and being more expressive about signatures. Because that's really what we've been talking about, being able to express in those more abstract languages of Smithy and TypeSpec. So those languages both have ways, as I said, DSL-style ways, essentially, of deciding that you can go and build libraries of your own decorators in TypeSpec or traits in Smithy to go and express things that are around the how you should use an API and perhaps why you should use an API. Whereas if you think of OAS 3.1, it's really great at expressing what the shape of an API is, but there isn't much semantic around it in the actual core standard. Being able to up-level that into the language at the OAS level will allow us, when we create those custom decorators, to not just treat them as notes against the design that we use at review time, but actually to flow that down through our toolchain. And flowing it down through the toolchain is pretty key to us then being able to do something concrete with it. So for example, if we're building our SDK generator, we can say, this was called up as a stepwise long-running operation for my forecast in my TypeSpec file. Now I can go and drill that through into my Moonwalk OAS as metadata in a way using standard semantic techniques. And then I can make an SDK generator that says, well, I should write some special code for long-running operations that when I call the operation automatically goes and does that polling loop for me and provides a faux synchronous operation. So I can give that experience and that much crisper and smoother user experience without having to know the fine details of the underlying raw API protocol to my person who's just coming along and downloading an SDK. So hopefully that's where Moonwalk's going to get us to. So, here's my call to action here. Please go ahead, investigate these new languages, whichever flavor takes your fancy. Obviously, you know, I have an opinion which one's great. And I think you'll find if you do and you can start to bring those into your processes, you'll make the life of your design folks and your governance teams quite a lot easier as they're not wading through thousands of lines of OAS and trying to work out what's important and which changes are important and which is just, you know, noise that's required for the implementation. Please, if you're able to, try and get involved in the Moonwalk effort. This next year is when we've got the chance to really influence the OAS language's next generation, and for you to influence it in a way that makes sure it can capture the types and styles of metadata that drive your business needs. You know, we don't want to come out of this as a community and go, yeah, well, you know, these guys over here thought that this would be important, and then us all be going, well, what about my stuff? So the only way to make sure we get the right stuff is to be involved. And then if you should happen to start trying out TypeSpec, we have, as I said, we've open sourced it. We've done that because we really want to build TypeSpec in the full glare of the community and get feedback and build it along with you and make sure we're building tools that work for everybody. So please come back, give us that feedback. I encourage you to go, and if you weren't in Mandy's talk yesterday, to once it goes up online, go take a look at that because she went in, you know, quite a bit deeper, particularly on the how the thing hangs together philosophically, and go and check out typespec.io for all the details and getting started. And what not to do. Obviously, as I said, you know, there's some things coming up that have some similarities. Let's not start any new API definition battles, right? So, with that, I'd love to talk to you during the day, but thank you very much.